This is the Carvera CNC machine, and this is the new Carvera Air CNC machine. The Carvera Air is a more affordable version of the Carvera, costing roughly half as much. But how does it compare to the original, and can you expect similar results? In this video I'm going to see how far you can push the accuracy and surface finish of both of these machines and directly comparing them against each other, so you can see what sort of results you would expect when machining aluminium on either of these two machines. I'm also going to be machining some other random bits along the way to show you what the Carvera Air is capable of. The first test that I'm going to compare these machines with is a simple surface finish test. I've got a piece of aluminium flat bar and I'm going to face it and then also take a little bit off the side. This will let me see what sort of floor finish and wall finish I can get on both machines. For this comparison I want to get a really good surface finish to see what the upper end of both machines is. So far I tend to just use single flute end mills on aluminium. They're cheap and the single flute makes them great for chip clearing and roughing on these very small hobby machines. I don't think this gives them the best surface finish though, because the single flute is quite unbalanced and it makes a kind of interrupted cut. In previous tests I've always thought that I should be able to get a better surface finish if I use a proper finishing end mill. So I've bought this nice 3-flute polished carbide finishing end mill with a diamond-like carbon or DLC coating that makes it look very nice and colourful. This claims to be made for finishing aluminium, so I'm also going to see if this gives an improved surface finish over the single flute end mill. Both machines are also equipped with an air blast nozzle, which should help with chip evacuation and cooling. And I'm finally going to put that to use. I've bought this small cheap airbrush compressor and we're going to see how well it does. So let's cut some chips. First we're looking at the original Carvera machine. First is the facing cut with the single flute end mill, and you can see that it's handling it very nicely. Though the airbrush compressor is quite loud, you can see it's doing a good job of firing the chips off to the left. Let's compare that cutting performance with the exact same parameters to the Carvera Air now. The cutting performance and surface finish seem largely the same at this point, although the sound of the cut is slightly different. Let's compare them side by side and see if we can notice any difference. Looking first at the Carvera. And then at the Air. Both machines seem very similar for this cut, but the Carvera Air maybe sounds slightly louder and it sounds like there's maybe a tiny bit more vibration, but it's a very small difference. Now onto the wall finish test, which I'm going to use a bit more of an aggressive cut with more tool engagement, with 4mm depth of cut and a very small step over of 0.2mm. You can see that the tool is cutting well and the chips are flying off very nicely, but it is a louder cut than the facing operation just because of the larger tool engagement. Now the same cut again, but for the Carvera Air, which also seems to handle it pretty well. Now for another direct comparison, here's the Carvera. And here's the Air. Again, pretty similar performance from both machines, although the Carvera Air does sound like the tool is vibrating a little bit more. I then finished half of that wall with the 3-flute finishing end mill. It was my first time using this end mill, and you can see from the chips flying off that it's cutting quite well. Same again on the Carvera Air. I then faced one half of the part with the finishing end mill so we can see how good of a floor finish it leaves. Surface finish from both machines seems pretty good, and it's really shiny with the finishing end mill. Later on in the video I'm going to measure these parts with some expensive metrology equipment so we can get some really detailed photos of the surface finish and measure the flatness. But before that I want to cover the machining of the accuracy test so I can compare everything at once. The accuracy test that I'm using to compare these machines is called a square diamond circle test, and apparently this is quite a common test used for evaluating the accuracy of CNC machines. So it's a pretty simple part with a pretty simple toolpath, nothing too fancy on this one. And as with the previous test, I'll be running identical G-code and tooling on both machines so we can directly compare them. Just with before, there's a similar cutting performance on both machines, but the Carvera Air seems to be vibrating a little bit more, and it's quite evident in this footage. You can see the camera is shaking around a little bit more, and the cut is definitely noticeably louder. Finishing this 14mm bore with a helical ramp toolpath, you can start to see a bit more difference between the two machines. The Carvera is handling it very nicely, but the Air seems to be vibrating a little bit more, and you can see the surface finish is a bit rougher. Occasionally the air compressor that I was using decides to spit out loads of water, and unfortunately it's done that on the Carvera Air finishing pass here, so it's hard to directly compare the footage, but I don't think that this really affected the surface finish. If anything, it might have even improved it slightly. Pretty nice surface finish all round though. I then break all the edges with a small chamfer, and after that it's onto the engraving. I'm using a 30° V-bit with a 0.2mm flat on the end for the engraving, and I don't think I've really got the settings right because it doesn't look like I've got the best surface finish on either machine for this one. Finally, I cut around the outside with the 1/8 inch end mill again, and just leave a few small tabs holding on the material that are very easy to break off and then file down. This is what the accuracy and surface finish tests look like side by side. And on first glance they're very similar and the differences are quite subtle, so I'm going to really zoom in so that we can analyse the differences. First, let's take a look at the surface finish test for both machines. It's quite hard to convey surface finish over video, and I myself don't have a very good way of measuring it. But you can see with these two videos that there's no massive difference between the two surfaces, although I would say that the machining marks for the Carvera Air look slightly deeper and the surface looks slightly more scratched up, but again, the difference is very subtle. That's as good as I can get with macro photography, so next let's look at it under a microscope. This is a CNC vision system which I have access to at the engineering company that I work at. It's kind of like a really expensive motorized microscope that you can also use to take very precise measurements. I'm not going to be using it to measure the dimensions of any of these parts, but I'm going to use it to get some high magnification images of the surface finish. It's really cool to be able to zoom in and see the individual machining marks from each rotation of the tool. Putting the surface of each machine side by side, it's really hard to tell a visual difference. It's the same story with the wall finish, where visually it's quite hard to tell the surfaces apart. So at least visually the surfaces are very similar, but that doesn't mean that they're the same. A surface finish isn't the only metric that you can compare these two machines with. Apparently, the human finger is so sensitive that you can feel differences in height of as small as 1 micron. When I run my fingernail along the Carvera machine surface, it runs very smoothly and it doesn't catch, whereas when I run it across the surface by the Carvera Air, there's more ridges in between the different stepovers of the tool, and my fingernail starts to catch a little bit more on those stepovers. This indicates to me that the machine surface of the Carvera is smoother and flatter than the one of the Carvera Air. So to quantitatively compare the flatness of the two surfaces, I can use this CMM machine to scan the surface. CMM stands for Coordinate Measurement Machine. It's like a very accurate CNC machine with a very small ruby probe on the tip, and it just touches the part and detects that contact and records the position of the probe in X, Y and Z very accurately. The first thing I did is take quite a detailed scan across the surface just in a line, so we can try and see the surface profile of some of those stepovers. This is what the results look like. The blue line is the Carvera and the red line is the Carvera Air. It's interesting that you can see the stepover of the machining marks in the data for both of the machines. The Carvera is flat to about 4 microns, and the Carvera Air has a surface deviation of up to about 10 microns, with the peaks and valleys between stepovers being about double as large on the Carvera Air. It's quite hard to visualize what that looks like in 3D, so I took a grid scan of the entire surface for both of the machine surfaces. This is what that looks like as a 2D heat map, where the colour is corresponding to the surface deviation of a perfect plane. And if I overlay an image of the surface, it's really cool to see those lines of the peaks and valleys line up with the stepovers of the tool. Here's what that looks like in 3D, obviously with the Z-axis very amplified. The maximum deviation for both machines over the plane is very similar. You can see that it's about 8 microns on the Carvera and 9 microns on the Carvera Air, but the average surface deviation of the Carvera is about a third that of the Carvera Air. The CMM software measures the flatness tolerance of that plane as 9 micron on the Carvera and 19 micron on the Carvera Air. Both of those are a pretty tight tolerance and could probably be improved by messing around with the feed and speed and the step over, but you can achieve about half the flatness tolerance with the Carvera versus the Carvera Air. Now I'm going to compare the square circle diamond accuracy test that I made. It's a similar story to before, where the parts look pretty similar visually and they're actually quite hard to tell apart, but there are a few more subtle differences in this one. The first is there are a couple of areas of the wall finish where you can see the tool has vibrated for the Carvera Air and it's not quite as smooth. And then secondly is some of that vibration has resulted in slightly more swirling and tool marks in the floor finish of some areas on the Carvera Air as well. But again, visually these parts are very similar, and unless you have them side by side, it's pretty hard to notice any difference. But the main thing that I'm interested with these parts is comparing the dimensional accuracy. So I put them both on the CMM machine and ran a comprehensive program to measure all of the features with a lot of different points. Once I had the program set up nicely, it was very cool to just be able to put the parts on and run them and watch it automatically measure all the features of both of these parts. Here are the results of these two measurements out of the CMM program. There are so many dimensions and data points to go over here that I'm not going to cover everything, and if you're really interested in individual dimensions, just pause the screen and have a look here. The CMM user interface is quite horrible, so I'll overlay some of the key findings on this high resolution scan that I took on the vision system so that they're a bit more visible. First, let's look at the width and height of both of the parts. Unfortunately, I kind of messed up on this dimension and I didn't actually use a finishing end mill to bring this down to size. I just kept with the roughing end mill and just cut around the outside. So both of these dimensions are a little bit oversized, but surprisingly enough, the nominal dimension is actually more accurate on the Carvera Air than the Carvera. The diameter of the bore is supposed to be 14mm and it's slightly undersized by 26 micron on the Carvera and slightly oversized by 56 micron on the Carvera Air. This circle is meant to be 45mm and it's 7 micron oversized on the Carvera and 19 micron oversized on the Carvera Air. Both of those nominal dimensions are really accurate, but they don't tell the full story. That's just the average size of the measured circle, but if I actually look at the CMM points for both of them, you can see there's quite a lot of variation from a perfect circle. You can see for both machines that as the cut is interpolating the circle, when it changes direction at the top or bottom of the circle, there's a bit of a step in the surface deviation, and that indicates that there's some backlash present in both machines for the Y-axis lead screw. Taking the variation of points from a perfect circle, the machine gives you a circularity tolerance of 51 micron and 52 micron for both of these machines. Finally, looking at the dimensions across the flat of the diamond, you can see that both machines actually have a pretty similar accuracy, with the Carvera Air actually coming out slightly more accurate on the nominal dimensions, but then when you look at how parallel the two lines are, then the Carvera is more parallel than the Carvera Air. And it was the same sort of story for the rest of the dimensions, where I would say in general the Carvera was slightly more accurate. It was able to hold a tolerance of about plus or minus 0.05mm for most features, and the Carvera Air was not far behind, maybe with a tolerance of plus or minus 0.1mm. Bear in mind that this is only a single data point for each machine. I don't really know how consistent the machine is, but I would imagine it's able to achieve these results quite consistently. And to be honest, I'm quite surprised at how well the Carvera Air kept up with the Carvera. Listening to the difference in cut quality and looking at the slight difference in surface finish, I wasn't expecting the dimensional accuracy to be this good. But the question still remains, why is there a difference in the cutting performance and dimensional accuracy of the two machines? The Carvera has an X-axis with fully supported square linear rails that are bolted onto a solid aluminium frame. This is great, but square linear rails are expensive, and also you have to bolt them onto a very flat surface, and machining that surface is also expensive. So to reduce costs for the Carvera Air machine, they've used these circular unsupported precision ground steel rods. And these are still really stiff, but I don't think they're as stiff as the fully supported linear rails of the Carvera. I think it's this difference in stiffness that's leading to slightly more tool deflection, and I think that's why we get slightly worse dimensional accuracy and surface finish. But I want to test that theory and directly compare the stiffness of the two machines. To do that, I want to apply a known force perpendicular to the spindle and use a dial test indicator to measure the deflection at the spindle. So I've designed this aluminium roller with some bearings in the middle. The idea is that you can hook a piece of string onto the spindle, put it over this roller, and then hang a weight off it, and that will apply a known force perpendicular to the spindle that could simulate a cutting load. This gives me a good excuse to show the machine making some functional parts so that you can see what it's capable of. There are two parts to machine here. The first one is a simple bracket to attach the roller to a piece of aluminium extrusion, and the second one is the roller itself. The roller is going to be a little bit more complicated because I want to make it on the 4th axis, then hold the circular piece upright and machine the hole for the bearings. So the brackets are nothing fancy, just a standard adaptive toolpath to remove all of the material, and then just the finishing passes that I've been using earlier to cut out the part. I made 2 of them, and you can see how they bolt either side of a piece of aluminium extrusion here. I then just need to make the roller that goes on the end. This roller is a great excuse to use the 4th axis add-on for this machine. The 4th axis for the Carvera Air has been greatly upgraded from the original 4th axis for the Carvera. It's now got closed loop stepper control that goes through a harmonic drive gearbox instead of the open loop belt drive on the old version. You can see that it's having no problem taking a relatively decent cut, and it's leaving a really nice surface finish as well. I formed the inside of the curve of the roller just by offsetting the end mill and using the side of the end mill instead of the end, and that meant that I could do this whole part with just a single end mill and I didn't have to use a bolt nose. Next I wanted to mill a pocket to put some skateboard bearings in the middle of the roller so that it would have really low friction. It would be possible to hold the round pulley with some of the clamps that come with the Carvera and the Carvera Air, but I often find myself wanting to machine the end of bits of round or square stock. The best way to hold this type of thing is in the chuck that you use for the 4th axis, and this can actually be unscrewed, and it's got an M14 by 1mm thread on it. So if I can replicate that thread vertically and have a subplate that will hold the chuck vertical, I can then easily machine the end of circular and square parts. So I went about designing just that, a vertical subplate for the chuck that has an M14 by 1mm thread, so I can just screw the chuck on and hold it vertically. Here's the design for the subplate. It's not the most simple implementation, but it'll be a good test of the machine. You can see it's made of 2 components. It's got the base plate and then it's got a circular boss that sticks up the middle, and that's got the M14 thread on it. The boss is clamped into the base plate with an M5 bolt on the bottom, and there's a 30-degree taper which locks it all together. I had to put some slots in instead of just bolt holes so that I can fit the chuck on both machines. The Carvera Air and the Carvera have slightly different positioning of the anchor point compared to the hole spacing of the bed. The toolpath was nothing too fancy, but there were quite a lot of individual features and setups that needed to be done. Starting off with the base plate, I've got this piece of 20mm aluminium. So the base plate came out pretty nicely. The next step is to make the threaded boss which bolts into the base plate. Ironically, I kind of need a vertical chuck subplate to make that piece, so I 3D printed the model out of PLA at 100% infill. I've left a lot of room around the bolts so the subplate can move around when you bolt it down to the bed. To perfectly line it up with the anchor point, I move the spindle to anchor point 2 and then lower it until I can tighten the chuck around the spindle. I then just do up all of the bolts and it should be roughly in the right position, at least close enough for what I need. The 3D printed subplate wasn't very stiff, so there was a little bit more chatter when machining on this. You can see that it really didn't enjoy this drilling cycle. I made a programming error in the finishing pass that I didn't catch when I was checking the program. I accidentally set the finishing pass to also finish the bottom of the inside threaded hole, ended up crashing the machine and scrapping this part. Thankfully nothing was broken and I could just rerun the toolpath with a new bit of round stock. The surface finish with the ball nose end mill was okay. I think I've not got the feeds and speeds nailed at the moment. I can then swap over to the aluminium subplate so that I can bolt in that piece and machine the M14 thread into the boss that's now sticking out. Unfortunately, I used the corner piece to align everything back to the origin, and I didn't really account for a difference in dimension between the 3D printed part and the aluminium part, so you can see that the boss is slightly off center. But that's okay, I think I'm going to remake it another time. For now, this is good enough. Thankfully, after all of the thread milling, the chuck threads really nicely onto the boss sticking up. This is exactly what I wanted. Now I've got a really nice way of holding the chuck vertically so that I can machine the end of round stock. Now it's finally time to machine the pocket for the bearing out of the roller. I wanted to get the fit for the bearings really close, so I measured them with a spring bore gauge and then slightly adjusted the stock to leave offset in Fusion 360 and reran the toolpath. I then flipped it over and did the same thing on the other side. You can see that the final fit with the two bearings came out really nicely. And I finally got my roller. Here you can see the setup. It's pretty simple. I've got a dial test indicator and a carbide rod on the spindle. Shoelace is tied around the spindle, then it goes over the roller and down to some weights. When I put some weights on the shoelace, it's then going to apply a perpendicular force to the spindle and I can measure the deflection. I've got weights of 3, 5 and 8 kilograms, and I'm going to be testing the Carvera Air in the very middle of its X travel where the deflection is going to be worst. I'm also testing the original Carvera and my homemade CNC router. And here are the results. First, the deflection of the Carvera, which gets up to about 0.25mm at 8 kilograms. Then we've got the Carvera Air, which gets up to 0.4mm at 8 kilograms, which is about 1.5 times more deflection under the same load. And finally we've got my homemade machine, which is somewhere in the middle, and I'm surprised it wasn't more considering how large the x-axis is. So I think that that increased deflection can help explain some of the differences we're seeing between these two machines. I've really enjoyed testing out these two machines and comparing them against each other, and I've been really impressed with how well the Carvera Air keeps up, considering it's half the price of the Carvera. If you were considering either of these two machines and you weren't sure what to choose, hopefully this video has helped you make a decision. If you're interested in buying either of these machines, have a look at the link in the description. This is an affiliate link, so I'll get a small kickback if you do purchase through it. If you have stuck around until the end, thank you very much for watching this far. I hope that you've enjoyed this video, and I'll see you in the next one.